When we think about kind of energy abundance, very futuristic, data centers in space is often kind of proclaimed to be this kind of holy grail, capturing energy from the sun. And how much of a solution is that versus a bluntly unrealistic pipe dream?
The atmosphere alone results in about a 30% loss of energy. So you can, for any given solar panels can do about 5 times more power in space than on the ground. And you avoid the cost of having batteries to carry you through the night. So it's actually much cheaper to do in space. And my prediction is that it will be by far the cheapest place to put AI will be space in 36 months or less, maybe 30 months.
Right now, chip cost is very high, and so that is by far the dominant cost. But if you include energy and infrastructure, you're talking about at least 30% of the cost. The main problem is, if you even, to build a new energy project terrestrially, you're looking at like a 5 to 10 year long lead time on just the permitting of that. Yep. We can deploy this stuff extremely rapidly. So even if we were break even on energy and infrastructure, it would still make sense to do this. But we're looking at doing this about 10 times cheaper on both energy and infrastructure. When I say infrastructure, what I mean is we don't need batteries, cooling towers, big chillers, backup power. All we need is a dirt cheap radiator.
And there's been talk about the next step is we're going to put things into space. And my question's always been I have a satellite with some GPUs, it's doing inference. But when you're literally spreading things out across thousands or hundreds of thousands of miles on a big network, it seems like you lose all of your advantage for speed. The speed of light is your enemy versus being in one center.
It's hard to envisage doing the sort of training that we do in our Stargate data centers in space. Just the latency would be a huge problem. And just the background rate of failures would be a problem. And just, we have technicians from Microsoft and Oracle who have to go in and fix things all the time, every day. Hard to do that in orbit.
Actually, it depends on how recent the GPUs are that have arrived. I mean, at this point, we found our GPUs to be quite reliable. There's infant mortality, which you can obviously iron out on the ground. So you can just run them on the ground and confirm that you don't have infant mortality with the GPUs. They're quite reliable past a certain point.
Space data centers effectively are not limited by, hey, we have this energy advantage. It's actually just limited by the same contended resource. We can only make 200 gigawatts of chips a year by the end of the decade. So what are we going to do to get that capacity? It doesn't matter if it's on land or in space. At some point, we do cross the chasm where space data centers make sense, but it's not this decade, right? It is much further out once you have energy constraints actually being a big bottleneck, once you have space land permitting be a much bigger bottleneck as it subsumes more and more of the economy, and chips are no longer the bottleneck.
I worked on the Mars missions, and I know how to produce water and breathing air on Mars. Trust me, it's really hard.
I wasn't doubting it, KR.
Okay, actually. you can squeeze water out of a rock, but why? There are better ways to do that right now on Earth.
My expectation roughly is that in 10 years, we might hit a point where most new compute capacity is being deployed in space. If you ask me, what is the total percentage of compute in space at that point, it's still probably less than 5%. In the same way, most new cars coming off a production line are electric. But if you want to know what is the percentage of the fleet which is electric, it's like 4% still. And it just takes a long time to replace all of the capacity that we're building on Earth terrestrially right now. So in 10 years, I would say most new compute capacity will be being built in space.